Hello everyone, welcome to the online platform of Hera Public School, Phadgudia, Azamgarh. I am Mohd Sadiq, a faculty member here, and this is our JEE Main PYQ, that is previous year questions series. In the last segment we were doing kinematics. आज हम वहीं से continue करेंगे. So let's get started and work through these questions together. Okay, so this is our first question today. It says a particle moving in a straight line covers half the distance with speed 6 meters per second. The other half is covered in two equal time intervals with speeds 9 meters per second and 15 meters per second respectively. The average speed of the particle during the motion is. Okay. So first let us understand what is given to us. So a particle moves, say, from point A to point B. Okay. So this whole journey has been divided into two equal lengths, into two equal segments of equal length. So say there is some point C. Now A to C and C to B are of same distance. So for first half distance, the particle is traveling with speed 6 meters per second. Okay, and the next half distance, so in the next half distance, this distance has been covered in two equal time intervals. So for example, the particle is moving from A to B, say this is 100 kilometer. So first 50 kilometer has been covered with 6 meters per second, and the remaining 50 kilometer, for first half time the particle was moving with speed 9 meters per second, and for the latter half time it is moving with 15 meters per second. So for example, say from C to B it takes 1 hour. So for half an hour it is moving with 9 meters per second, and for the next half an hour it is moving with 15 meters per second. This is the question. Okay, so and we have to find the average speed for the entire journey. Okay, now let us understand this whole case in its entirety. So we know that average speed is distance upon time. So from here, if we are given speed and time, we can find the distance traveled. If we are given speed and distance, we can find the time taken by the particle. So suppose this is the case. A particle moves from A to B and then from B to C. A to B has been traveled with speed v1, and from B to C it was moving with speed v2. And for A to B, the time taken is t1, and for B to C, the time taken is t2. Now, how to find the average velocity for the whole journey? So average velocity is total distance. Now what is total distance? A to B distance has not been given to us directly. So how to find this distance? It is moving with this constant speed. So A to B distance would be simply speed into time, that is v1 t1. Okay. Similarly, B to C distance would be v2 t2. Okay, this is total distance traveled by the particle, now divided by the total time, which is t1 plus t2. Okay, now let us consider a special case here, that these intervals, these times are equal. That is, t1 is equal to t2, and say this is equal to t. So what would be the average speed in that case? So I can put t here and also t here. Let us take that t as common, and v1 plus v2 is left in the bracket, and in the denominator I can write 2t. So this t and this t, they get cancelled. So what is left? V average in that case is v1 plus v2 divided by 2. Okay, what is this? We can say this is mean value of v1 and v2. Similarly, if the journey is being divided in 3 segments of equal time interval, then the average speed would be v1 plus v2 plus v3 divided by 3. Okay, so every time when time taken by the particle is same, the average speed is nothing but the mean value of different speeds given to us. Okay, so this is first case. Now let us consider another case. Now in this scenario, the particle travels from A to B and then from B to C. And in this case, the time taken by the particle for A to B and B to C is same. Okay, but let us first consider we are given, say this distance is S1, okay, and B to C distance is S2. and A to B, the velocity has been v1, and for B to C, the velocity was v2. Okay. Now, how to find the average velocity in this situation? So, average velocity is total distance, which would be simply s1 plus s2, and divided by total time, which is not given to us directly. So, how can we find time? We can find time as distance divided by speed. So, for this segment, time is s1 upon v1, and for this segment, it is s2 upon v2. Okay. Now, let us consider the special situation where s1 is equal to s2. That is A to B distance and B to C distance. These distances are same. Okay. Or we can also say that A to B is half of the whole journey. So, A to B is first half distance, B to C is latter half distance. So, in this case, S1 is equal to S2, say these are equal to S. So, what is average speed in that case? This is simply S plus S2S divided by S upon V1 plus S upon V2. Let us take S as common. So, what is left in the bracket? It is 1 upon V1 plus 1 upon V2. So, S and S ये cancel हो गए यहाँ से, and we can simplify it. This 2 will come here, V average upon 2, and then take the reciprocal on both ends. So, this is 2 upon V average is equal to simply 1 upon V1 plus 1 upon V2. This is how we would find the average speed when distances traveled are equal. Okay, so this whole journey has been divided into two segments of equal distances. The formula is 2 upon V average is equal to 1 upon V1 plus 1 upon V2. If the journey has been divided into 3 equal segments, it would be 3 upon V average is equal to 1 upon V1 plus 1 upon V2 plus 1 upon V3. Okay, this is the case. We have to solve the question given to us considering these cases. Okay, the question is A to C distance and C to B distance. These distances are same. So, first half for the first half speed is 6, and for the next half we don't know the speed. If we could know the speed, then the average speed for the entire journey will be simply 6, and say for the latter half the speed is some V divided by, no, not. When distances are same, we write it like this: 2 upon V average is equal to 1 upon 6 and then plus 1 upon V. Okay, so what is left to know, that is the value of this V. If we can somehow find the value of V, we can find the average speed for the entire journey. Now, how to find this value? In this latter half, this journey has been traveled in 2 equal time intervals. So, when times are same, when the durations are same, average speed is simply the mean value of these speeds, which is 9 plus 15 divided by 2. 9 plus 15 is 24, divided by 2 is 12. So, 12 meter per second. So, in the latter half, average speed comes out to be 12. So, let's just put that here. So, 2 upon V average is equal to 1 upon 6 plus 1 upon V, which is now 12 meter per second. So, 1 upon 6 plus 1 upon 12, I can write it as 2 upon 12 plus 1 upon 12, that would be 3 upon 12, and 3 upon 12 is 1 over 4. So, 2 upon V average is equal to 1 over 4. So, from here V average is equal to 8 meter per second. This is the answer to this question. That is, the fourth option is the correct one. Okay, so this is how we would find the solution to this problem, and these kinds of situations are very common in competitive exams. In various exams, they ask the question on these patterns. So, what is the pattern? You have to consider two situations: when the average, when the distances travelled are same, and when the durations are same. When distances travelled are same, how to find the average speed? When durations are same, then the average speed is simply the mean value of different speeds given to us. Okay, let's move on to the next question. This is the second question. Two cars are travelling towards each other at speed 20 meter per second each. When cars are 300 meter apart. Both the drivers apply brakes and the cars retard at the same rate of 2 meter per second square. The distance between them when they come to rest is. Okay, so this is the question of relative velocity. Two cars are moving simultaneously and speeds दी हुई हैं, उनके accelerations, retardations दिए हुए हैं, and we have to work on this this situation. So first of all, in case of relative velocity, let us consider a situation. Say a car A is moving with speed 10 meter per second, and another car B is moving with speed 15 meter per second. Then how fast B is moving as seen from A? When someone observes B sitting inside A, how he would record the speed of the car B? So surely this is just 5 meter per second. With respect to A, B is moving only with a speed 5 meter per second. Okay. Now suppose the situation when A is at rest. This is at rest, and the car is moving. The car B is now moving with speed 5 meter per second. Okay. So in this situation, the velocity of car B with respect to A is simply 5 meter per second, and in this situation, it is also 5 meter per second. Now, aren't these two cases the same? So in this case, say in 10 seconds, how far ahead B would be from A? So in 10 seconds, the B would travel a distance 50 meter with respect to A. So if they are now parallel, they are now side by side, then after 10 seconds, car B would be ahead by 50 meter from A. Now in this case also, B would be ahead by 50 meter with respect to A. So if we can now, what is the point that I want to make here? That is that if we can find the relative velocity of a particle with respect to another particle, then if it is same, if we can assume that the other particle is at rest. Okay, so if A is at rest and B is moving with 5 meter per second, and if A is moving with 10 meter per second and B is moving with 15 meter per second, these two situations are same in terms of distances traveled with respect to each other. Okay. So whenever we can find in one-dimensional motion, we can find the relative velocity of one object with respect to the other, we can take other object to be at rest. Okay. So what is the situation given to us? We have two trains. Okay, say this is train A and there is another train B. They are moving with same speed, 20 meter per second. 20 meter per second. Okay, towards each other. So what is relative velocity in this case? Suppose A moves 1 meter and B also moves 1 meter in 1 second. So with respect to A has moved 2 meter per second. Okay, so in this situation, the velocity of A, let us say this is initial velocity. Velocity of A with respect to B would be simply 40 meter per second. When they are moving opposite to each other, we simply add the speeds of the two objects. And then, okay, the initial distance between them is 300 meter. This is 300 meter. And then both retard at 2 meter per second square. Again, so for the retardation for A is towards left and retardation for B, that means the direction of acceleration of A is towards left and for B it is towards right. Again, these two accelerations are opposite, so the relative acceleration would be, acceleration of A with respect to B would be simply 2 and 2, that is 4 meter per second. The retardation, okay, the retardation of one train with respect to the other is 4 meter per second square. And finally, they stop. So finally, relative velocity will be 0. So final velocity of A with respect to B would be 0. Okay, and now we can easily say that one of the trains is at rest. So let us say train B is at rest. So what is the distance traveled by train A? So train B is at rest. What is the distance traveled by A before it stops? So we can use the third equation, which is V square is equal to U square plus 2AS. Final velocity is 0. Initial velocity with respect to each other is 40 square, and this is retardation, so minus 2, A is 4, and S. So from here, S is 40 into 40 divided by 8, and that would be 5 times, this is 200. Okay, so distance traveled by train A with respect to train B is 200 meter. Okay, now in the question, we are being asked what is the distance between them when they stop. Okay, so if a train has moved 200 meter, what is the remaining distance? It is simply 300 minus 2. Okay, so distance between them is 300 minus 200, that is 100 meter when both trains stops. Okay, so this was the question and all the relevant cases related with this question. Next question is position of an ant S in meters moving in YZ plane is given by S is equal to 2t square j cap plus 5 k cap, where t is in second. The magnitude and direction of velocity of the ant at t is equal to 1 second will be. So this is very straightforward question. We are given the position of the particle or the ant moving, which is 2t square j cap plus 5 k cap, and we have to find the velocity at t is equal to 1. So how to find the velocity from position? It is very simple. We have discussed these kinds of situations earlier. This is simply rate of change of distance, ds over dt. So if we differentiate this, this becomes 4t j cap, and this is constant, it is 0. Now velocity, this is velocity at any time. So what is the velocity at t is equal to 1? So just put t is equal to 1, v is equal to 4j meter per second. So which option is the right one? It is along y direction, and the magnitude is 4 meter per second. So the fourth option is the correct answer. Okay, so very straightforward kind of question. Let's move on to the next question. Now it says a particle starts from origin at t is equal to 0 with a velocity 5 meter per second and moves in xy plane under action of a force which produces a constant acceleration of 3I plus 2j meter per second square. If the x coordinate of the particle at an instant is 84 meter, then the speed of the particle at this time is square root of alpha meter per second. The value of alpha is. Okay, so what is given to us? We are given the initial velocity as 5I meter per second. So say u, vector u is 5I meter per second, and the acceleration. So acceleration vector is 3I plus 2j meter per second square. Okay, and then what they are saying further, that the x coordinate of particle at certain instant is 84 meter. So at some moment x is equal to 84 meter. Now at the same moment you have to find the speed of the same particle. Okay, so we need to find the speed of the particle at certain moment, and how to find that moment? For that we are given that at that moment x is equal to 84 meter. So if you can use this information, we can find the time, and then at that time we have to find the speed. Okay. Now how to find the speed? We are given initial velocity and the constant acceleration, so I can make use of the first equation, which is u plus at. So u is given to us, a is given to us, we just need to find the time. At what time we are being asked the speed of the particle. Okay, so let's find out. Now x coordinate is 84 meter. So let us solve this question only along x-axis. So along x-axis, initial velocity is 5 meter per second, and along x-axis the acceleration is 3 meter per second square, and then at some time x coordinate or displacement along x-axis is 84 meter. So let's use the second equation. So second equation along x-axis is equal to x is equal to ux into t plus half ax into t square. Now let us put the values. X is 84 meter, ux is 5, and t plus half, a is 3, and t square. So this is a quadratic equation in t. So let's divide the whole, let's multiply the whole equation by 2. So this becomes 168 is equal to 10t plus 3t square. And let's take everything on one side. So this is 3t square plus 10t minus 168 is equal to 0. So this is a simple quadratic equation. If you multiply 3 and 168, we get minus 168, we get negative 504. So we have to split this middle term in such a way that the product is 504. So I can write it as 3t square and plus minus 18t plus 28t minus 168 is equal to 0. You can work through this easily. Now how to solve further? 3t, let's take 3t as common, so we are left with t minus 6 and then 28 here. This would be also t minus 6 is equal to 0. So we have two factors, t minus 6 and 3t plus 28 is equal to 0. Certainly t minus 6 is 0 is the solution, that is t is equal to 6 seconds. So the moment when x is equal to 84 is t is equal to 6. Now we have to find the speed at this particular moment. So now use this equation, v is equal to vector u, which is 5i, plus vector a, which is 3i plus 2j, and then into t, which is 6 now. So 6 into 3, that is 18i, plus 5i, that would be 23i, and then plus 6 into 2, that is 12j. So this is the velocity vector at t is equal to 6 seconds. Now what is the speed? So simply speed is the magnitude of this vector, which is 23 square plus 12 square. Okay. So 23 square would be 529 plus 144. This is 673. Okay. Now, so this is the speed at t is equal to 6 seconds, and question में क्या दिया हुआ है कि the speed of the particle at this time is square root of alpha. So what is the value of alpha? That means we don't have to calculate this square root, simply this is alpha. Okay, so the value of alpha is 673. Okay, so this is the numerical answer type question. The answer is 673. Okay, this was the question. Now let us take the next question. It says a bullet is fired into a fixed target, losing 1/3 of its velocity after traveling 4 centimeter. It penetrates further d into 10 raised to the power minus 3 meter. Before coming to rest, the value of d is. Okay, so the situation is a bullet is entering into a fixed target with some velocity. Say the velocity is u with which the bullet enters. And then after traveling 4 centimeter inside the target, it loses 1/3 of its velocity. That means the velocity would be u minus u by 3, that is 2u over 3. So what would be the distance that it further travels before coming to rest? So say the bullet stops here, and say this is some distance s2. Let us take this distance s1 and further distance as s2. So we have to find this s2. This is the situation, and what is the catch in this case? That the bullet is moving through the fixed target. In that case, the retardation offered to the bullet is same throughout. Okay. Now, how to solve this problem? We can use the third equation, which is v square is equal to u square plus 2as. For the first case, when it loses 1/3 of its velocity, let's write the equation. Final velocity is 2u over 3. That would be 4u square upon 9. Initial velocity is u square, and in the case of retardation, minus 2a, and distance traveled is s1. So let us take this on the left hand side. 2a s1 is equal to u square minus 4 over 9. U square minus 4 over 9 u square. This would be 5 by 9 u square. So 2a s1 is equal to 5 over 9 u square. Say this is our first equation. Okay, in the next case, for the distance s2, initial velocity is 2u over 3 and the final velocity is 0. So again, using the third equation and also using the same value of retardation. So final velocity is 0, initial velocity is 2u over 3, that would be 4 over 9 u square minus 2a and now s2. So now 2a s2 would be simply 4 over 9 u square. This is our second equation. This is the second equation. Now we have to find the value of s2 using these two equations. So this is very simple. You will be able to see we can divide these two equations. So let us divide equation 1 with equation 2. By equation 2. So 2a s1. So 2a on both on the left hand side will be cancelled. So s1 upon s2 is equal to u square. ये भी cancel हो जाएगा. So 5 over 9 divided by 4 over 9, that we can write as 9 over 4. So 9 ये cancel हो गया, and this is 5 upon 4. S1 upon S2 is equal to 5 over 4. Now S1 is 4 centimeters, so S2 would be 4 into 4, that is 16 upon 5 centimeter. And if we write it in decimal, this is 3.2 centimeter. But we have to express it as d into 10 raised to the power minus 3 meter. So if you convert this in meter, this is 3.2 into 10 raised to the power minus 2 meter. And if you can make this factor 10 raised to the power minus 3, then this would be just 32. Okay, so this is the distance further traveled by the bullet before stopping. Now, if we compare this result with the value given to us in the question, d into 10 raised to the power minus 3 and 32 into 10 raised to the power minus 3, certainly the value of d should be 32. But this is not given in any option, so this is the bonus question. Okay, no option is correct in this question. Let's move on to the next question. In this question, it says a body falling under gravity covers 2 points A and B separated by 80 meter in 2 seconds. The distance of upper point A from the starting point is in meter. Okay. So something is falling, and during its fall, it passes 2 points. Say first point is A and the second point is B. These 2 points are separated by a distance of 80 meter, and the duration the particle takes in going from A to B is 2 seconds. Okay? And question में हमसे क्या पूछ रहे हैं कि ये A से कितने ऊपर से ड्रॉप किया गया? What is the height above A the particle was dropped? So say this is the point. This is the point, okay, and at this point u is equal to 0. So we have to find out this height above A from where the particle was dropped. Okay. Now this could be a little tricky. If we are good at practice, we can solve this in a minimal way. Let us see. This distance is given to us and the time taken by the particle is given to us. Suppose at A the velocity is v1 and at B the velocity is v2. And we have seen in previous segments, when a particle moves with a constant acceleration, the average speed can be written as simply the mean value of initial and final speeds. So what would be average speed here? v1 plus v2 divided by 2. And we can also write the same average speed as total distance upon total time, that is 80 over 2. So this is 80 over 2, that is 40. So from here v1 plus v2 is equal to 80. This is our first equation. Now let us make use of the third equation for the journey A to B. So how would we write the third equation? It is v square is equal to u square plus 2gh. Final velocity is v2, so v2 square is equal to v1 square plus the body is moving downwards, so 2g and h की जगह पे हम use कर सकते हैं 80. So let us use the values. G is 10, it is given to us also in the question, and h is 80 meter. So let's take this v1 on the left hand side. v2 square minus v1 square is equal to 2 into 10, that is 20 into 80. Okay, now how can we write v2 square minus v1 square? We can write it as v2 minus v1 into v2 plus v1, and that is 20 into 80. Okay, now we know the value of v1 plus v2, that is simply 80. So v2 minus v1 into, this is now 80, is equal to 20 into 80. So ये 80 दोनों साइड से cancel हो गए, and now we have v2 minus v1 is as 20. So this is second equation. v1 plus v2 is equal to 80. This is first equation. So from these two equations we can easily find the value of v1 and v2 separately. So now let's write first equation, that is v2 plus v1 is equal to 80. So if we add these two equations, 2v2 is equal to 20 plus 80, 100. So v2 is equal to 50 meter per second. Now if v2 is equal to 50 meter per second, certainly v1 is equal to 30 meter per second. Okay, so at A, velocity is 30 meter per second. And from the point where the particle was dropped from, the speed is 0. And we have to find this distance. So for this segment, again we will use the third equation. V square is equal to u square plus 2gh. U is 0, so simply v square is equal to 2gh. So v square, what is velocity here? v1, that is 30. So 30 into 30. 30 into 30 is equal to 2 into 10 into h. So this is 15, 15 into 3 is 45. So h is equal to 45 meter, or the height above A where the particle was dropped from is 45 meter. So this is the answer to this question. Okay, so this was the numerical type question. But in numerical type question, we have to be very careful how they are asking the numerical value. So it is simple, the distance of upper point A from the starting point. Okay, so simply this value is also the answer. But in the previous question, what we calculated S2. S2 is equal to some 3.2 centimeter, but we had to convert this in some other form. And also in the previous question, the value of speed was under root 673, but we have to find the value of some alpha, which is under a square root. So be very careful in numerical type question how they are asking the question. Okay, so this was the question. Now let's move on to the next question. A body starts moving from rest with constant acceleration, covers displacement s1 in first p minus 1 seconds and s2 in first p seconds. The displacement s1 plus s2 will be made in time. So we have to find the value of that time in which s1 plus s2 distance is made by the particle, by the body. Okay. So what is given to us? The body starts moving from rest, initial velocity is 0 and the acceleration is constant. And in first p minus 1 second, okay, so p minus 1 is some time duration. In that time duration, distance is s1. But this time duration is taken from the starting point. Okay. And also s2 in the first p second. So again starting from t is equal to 0, In p second, distance is s2, and in p minus 1 second, distance is s1. So how to write these informations in equation? So we can make use of the second equation, which is s is equal to ut plus half at square. So for p minus 1 second, distance is s1, initial velocity is 0, so half a and p minus 1 whole square. Okay, and for the s2 displacement, s2 is equal to, again u is 0, so simply half a, and now the time is simply, where is the time? Okay, this is the time p, so p square. And now we have to find the time in which the particle will move a distance s1 plus s2. So this could be very simple if you look at carefully, if you look at, if you observe it in a focused manner. You can let us add these two equations. Let us so on the left hand side it would be simply s1 plus s2, and we can take half a as common. Then what is left in the bracket for us? We can expand this p minus 1 whole square as p square minus 2p plus 1, and then this p is p square, so half a, and in the bracket we have 2p square minus 2p plus 1. Okay, if we can write this in a manner, half at square, on the left hand side it is some distance, on the right hand side it is half at square. So anything that is multiplied by half a, or the coefficient of half a, is nothing but the time squared. So this is the time this is the time squared, which is 2p square minus 2p plus 1. So what is the value of that time? It is simply under root 2p square minus 2p plus 1. So this is the time in which the particle moves distance s1 plus s2. Okay, so which option is answer for us? This is the second one. Okay, the second option is the right answer. Okay, so again, conceptually this is a very straightforward question, but you have to be very careful and you have to be very good at practice so that you can see how to move forward from the information or from the equations that you form on the basis of information given to you. Okay, today's last question. A ball rolls off the top of a stairway with horizontal velocity u. The steps are 0.1 meter high and 0.1 meter wide. The minimum velocity u with which the ball just hits the step 5 of the stairway will be, again this is numerical type question and be very careful, कैसे दिया हुआ है हमें, will be square root of x meter per second, where x is. So the value of x is to be found out. Okay, so there is some stairway. Let's make the diagram. Stairway, this is the first step, second step, third step, fourth and the fifth step. Okay, and a ball rolls from the top step. It is moving with a horizontal velocity u. Okay, and then it moves from the edge and simply just lands on the fifth step. This is step 1, 2, 3, 4 and 5th. Now, what is meant by ball just hits the step 5? Just hits the step 5. Okay, that means the ball. Okay, iska matlab the ball was moving just touching the edge of the step 4. Okay, something like this. Okay, it started. It rolled off the edge of the top step and something like this. Okay, it landed on the step 5, but it just missed the edge of the 4th step. This is meant by just landing on the step 5. Okay, so if we look carefully, what is the distance traveled by the ball in the horizontal direction? This is the length of the 4th steps, the horizontal lengths, 1, 2, 3 and 4. So say if the width of the steps is a and height of the steps is b, then this whole distance is simply 4a, and the height descended by the ball is also equal to the 4 times the height of each step. Okay, ball is here when it just passes the edge of the 4th step, so it would be simply 4b. Okay, so this is nothing but the case of horizontal projection. We have studied horizontal projection in previous segment. Initial velocity is totally horizontal, and horizontal direction में acceleration 0 है, initially vertical direction में velocity 0 है, so we can find the time it takes to come down the height 4b. So we can directly use the standard results starting from 0. The time taken by the object in descending height h is simply under root 2h upon g. And in this same time, it moves a distance 4a horizontally. So there is no acceleration in the horizontal direction. So distance traveled is equal to speed into time. This is the time, 2h upon g. Now, how to write this h here? This h is nothing but 4b. So this is 4b. Okay, so from here we have to find the value of u. So let's put the values here. 4 into width of each step is 0.1. This is u, and in the square root 2 into 4 is 8, and height of each step is also 0.1 upon g, which is 10. Okay, now we have to find the value of u. Let's square both hand sides. This is 0.4 is equal to u square. This is 0.8 upon 10. If you can take, this is 0.4, and we are squaring both hand sides. So let's write 0.4 into 0.4, and this is u square is equal to, u square into 0.8 upon 10. Okay, so 0.4 will go 2 times in 0.8, and this 10 will make 0.4 as 4. So 4 divided by 2 is u square. So u square is equal to 2. Now let us see how they are asking. They're saying that the minimum velocity u with which the ball just hits the step 5 is under root x. Okay, so we have found that u square is equal to, what is the value? U square is equal to 2. So u is equal to under root 2. So compare it with the value given to us, under root x. So the value of x is simply 2. The numerical value of x is 2. So 2 is the answer to this question. Okay, so this was today's whole segment. I hope you have got some help from our discussions, and I will be very happy to know your comments, your suggestions, how we can do it in a much better way. That would be very grateful for us. Okay, so this is it for today. See you very soon. Thank you.